Now to morph our ideas of sine, cos, and tan, our trig ratios, and this idea of rotating and getting angles so that we can talk about the sine, cos, and tan of different angles on the coordinate plane. So we're going to do this problem here that says find the exact value, which means we are getting fractions. So our answers are going to be fractions of the 6 trig ratios, so sine, cos, tan, secant, cosecant, and cot. Of this little symbol here is called theta. It's a Greek letter. Essentially that stands for our reference angle. Given the point -4, -6 is on the terminal side of theta in standard position. So that means we're starting here in standard position. There's my initial side. And then my terminal side is going to rotate until I get to the point -4, -6. So -4, -6 will be down in the third quadrant. And I'm just going to put it right there. So now on this picture, I know theta, our reference angle, is in between the terminal side and the x-axis. So this is our theta. And the way we've drawn our picture here, we are set up right now to draw a right triangle from the origin over here to the left and then down to that point there. That way our reference angle is encompassed inside of this triangle, inside of this right triangle. And by also doing that, we know the two sides, the two legs of this triangle. This is going to be -4, and then this side is -6. Now it might seem funny to have the negatives there, but we are going to use them because the negatives are pointing out our direction that our triangle is facing. And once we have those two sides, we could figure out the hypotenuse of our triangle by doing Pythagorean theorem. 6 squared plus 4 squared, which will be 36 plus 16, which will be 52. So this will be radical 52. And now our picture is all set up. Now the easy part comes along. We're just going to give our 6 trig ratios. So we'll start with sine of this reference angle theta. Sine is opposite over hypotenuse. We'll do cos next. Cos is adjacent over hypotenuse, so adjacent to theta is -4, and the hypotenuse is radical 52. Next up, we'll do tan, which is opposite over adjacent, so from theta, opposite is -6, adjacent is -4. And you could reduce this to +3/2 if you so chose. And then we'll do the 3 reciprocal trig functions. So let's start with cusk. Cusk is the reciprocal of sine. So I'll just take my sine answer and reciprocate it. So -6 over radical 52 will be radical 52 over -6. And then secant is the reciprocal of cos. So if cos was -4 over radical 52, secant will be radical 52 over -4. And then lastly, cot will be the reciprocal of tan. So it'll be -4 over -6, or 2/3. And then, as always, we should be on the lookout for any of those 6 ratios that have radicals in the bottom. Sine and cos appear to have those, so let me get rid of those radicals in the bottom by multiplying by radical 52 top and bottom. So let's try this out on another problem. This one, the directions are a little bit different. Given the quadrant of theta in standard position and a trig value of theta, find the exact values for the other trig ratios. So our terminal side, here's our initial side, and then our terminal side is going to be in quadrant 2. So I'm going to rotate to quadrant 2. Label our reference angle between the terminal side and the x-axis. Here is our theta. And then we'll draw our right triangle here down from the tip top, down to the x-axis, back to the origin, so that way our right triangle has the theta inside of it, our reference angle inside of it. And now we can label that the sine of theta is 4/7, or our opposite is 4 and our hypotenuse is 7. Then we can use Pythagorean theorem to figure out our adjacent side to theta. So this will be 7 squared, take away 4 squared. 49 take away 16 will be 33. Radical will be radical 33. And one thing you're going to need to be careful of here is on this triangle, when you start at the origin and go to the left for this radical 33, we need to put the negative sign there to give it that direction that the triangle is kind of headed to the left of the origin. And now it's just a matter of going and getting our other 5 trig functions. So cos theta would be adjacent over hypotenuse. Tan theta will be opposite over adjacent, so the opposite is 4. The adjacent is negative radical 33. And then we'll do cusc next. Cusc is the reciprocal of sine, so if sine was 4/7, cusc is 7/4. Sec is the reciprocal of cos, which will be 7 over negative radical 33. And then lastly, cot will be the reciprocal of tan. So if tan was 4 over negative radical 33, cot will be negative radical 33 over 4. And again, you should get rid of the radicals in the denominators here. So this would be 4 radical 33 over negative 33. And this would be 7 radical 33 over negative 33.